Denton, let's read example number 7.
A coin is tossed and a 6-sided die is rolled. Find the probability of getting a head on the coin and a 6 on the die.
I'm recording, by the way. All right. Coin and 6-sided die. So I'm going to write 6 on this one. How many sides do I have in a coin? 2. So we're looking for a probability where I'm going to get head on the coin and then a number 6, the number 6. So how many heads do I have in one coin? 1 out of how many total sides? 2. And then how many number 6s do I have in one dice? 1 over 6-sided, so 6. So that's going to be 1 over 12, and that's it. Everyone good with that? Okay? Okay, the next one. Bryn, let's read.
What is the probability of choosing a heart and choosing a 3 without replacing the card?
So we're looking at a heart, and then choosing a 3. And then we have without replacing. Go ahead and underline that big time. So we're looking at deck of cards. So if we're looking at a deck of cards, we're looking at the probability of choosing a heart. You can draw the image heart. And the number 3. So if you're not familiar with the deck of cards, this may be a good time to listen very carefully. So how many hearts do I have in a whole deck of cards? 13. So just to kind of reiterate, there are 52 cards, correct? Okay, and we have 4 suits. Heart, diamond, what else? Spades and clubs, and they all come in 13 sets each. Good? So we have 13 of them. So I have 13 out of 52. And then it says, oh, I wrote 25. Oh, goodness. I would. And then because it says without replacing, so once you hold on to the one card, we're not replacing anymore. So now I don't have 52 cards anymore, but how many? 51. That's going to go on the bottom. How many number 3s do I have in the whole deck of cards? 4. So each of them has, for this one, 3 of hearts, 3 of diamond, 3 of clubs and spades, right? So we have 4. And then I think I'm going to type this in. So we have alpha y equals 13 over 52. And we're going to multiply that by 4 over 51. Oh, it gave me an error. Well, delete that. 1 over 51. Do we agree on that? Okay, hopefully you did physically type that in. It is 1 over 51 and done. All right, Johnny, let's read number 9.
What's the probability of choosing a heart and choosing a 3 after replacing it?
Now I'm replacing it, meaning I'm not keeping the card anymore. So we now have our probability of choosing a heart and a number 3. We know our first one is 13 over 52. The next one is 4 over how many? 52, because I'm replacing the card back. Now let's type that in. I think I'm going to go over to what I entered and modify the bottom. So you can always hover over, enter it. It'll give you the original that you typed in. Did we get 1 over 52? Is that a yes? Okay. Okay, my next one. Athena, let's read the scenario for the next one right here. This guy right here.
What is the probability of flipping a coin 3 times and getting 1 heads and 2 tails?
Okay, we're going to flip a coin 3 times. So when I flip the coin the first time, what are my options? I could either get a head or tail. So let's write H and T and kind of separate it because it's going to create a little tree. Let's say you got a head on the first flip. Your second flip, you can get heads and tail again. And then the next one also heads and tail. So here I have my first flip, second flip, and third flip. So keep making that tree. Head and tail. And repeat it. And let's see how many options we have. We have, it'll be our 1, 2, 3, 4, 5, 6, 7, 8 total outcomes. 8 total outcomes. Do we all agree on that? Yes? Okay, so I'm going to put on here, we have the probability. Now it says I have 1 head and 2 tails. So 1 head and 2 tail. Our total is 8. And then if you have a highlighter, it might be an ideal situation. I'm going to highlight to the piece where we can find 1 head and 2 tail. So we have 1 head and 2 tail. Would you agree that I have it right here? Head, tail, and tail, correct? Okay, over to the other side. I have tail, head, and tail. That's 2 heads or 1 head and 2 tails. And then I have another one right here. So how many lines have I drawn? 1, 2, 3. So 3 out of 8. So if you physically draw out the tree, you can visually see it. Everyone go with that piece. Okay? The next one, Nathan, let's read example number 10.
You have 3 cookies. What is the probability of picking bread and meat using the oatmeal, the chocolate chip, and the peanut butter and glass?
Okay, so let's underline. I want the oatmeal first. What's the other one? Chocolate. And then we have peanut butter. So let's see how many choices we have. I can choose to eat oatmeal, chocolate, and peanut butter. Or I could have oatmeal, peanut butter, and then chocolate. So O's are done, right? Now let's go to our chocolate. I could do chocolate and what else? Chocolate, peanut butter, and then oatmeal. There's another chocolate, oatmeal, and peanut butter. So C's are done. Now let's go to our peanut butter. What could the next order for the peanut butter be? Peanut butter, chocolate, and oatmeal? Somebody's not listening. Right with me? And then we have peanut butter, oatmeal, and chocolate. So how many options do I have total? So we have 6 total outcomes. 6 total outcomes. But I want that specific order. Oatmeal, chocolate, and peanut butter only happens 1 time, so it'll be 1 out of 6. And that is our final answer. Now go to page number 4. And let's highlight permutation and combinations. So when you're working on the quizzes homework, you'll be doing the independent and dependent, and then permutation and combinations. There's a lot of probability topics. So let's all highlight that right there. The only one that I'm going to actually use a formula and also maybe not the calculator all the way, it's going to be my permutation. Let's start with this guy first. Combination is where order matters. Order doesn't matter, my bad. And permutation will be when order does matter, and that same kid is talking over me. And when order matters, it's basically saying winning first, second, and third, the order does matter, right? Okay? So then let's go on to our combination question first. I'm going to go ahead and circle the 2 combination questions, number 12 and number 14. Okay, on number 12. Chelsea, let's read that one out loud.
When you order a sandwich at Nellie's Deli, you can choose from 4 kinds of bread and 7 kinds of meat. On any sandwich, you can have mayonnaise or mustard or both or neither. How many different sandwiches can you order?
So within the sandwich, we're looking at 4 kinds of bread, 7 kinds of meat, and what about our condiments? You can have mayo, mustard, both, or neither. How many options was that? 4. So we're going to look at sandwiches, and then we have the meat, and then we have the condiments. So we have the bread. Oh, that's not bread. That's bread now. Meat and condiments. So we have 4 kinds of bread, 7 kinds of meat, and 4 options for the condiment. And all you have to do at this point is multiply them. Let's do that. 4 times 7 times 4. Okay, someone tell me what they got. How many options do we have? 112 options. And I know you're like, whoa, is that possible? Yes, it is. Now let's go to number 14. Okay, on number 14, Alexa, let's go to read that one out loud, please. Okay, from A to D. So to get from A to D, I have to go to B to C to D, correct? So let's see how many options I have. How many options do I have to go from A to B? 3. How many options from B to C? 2. How many from C to D? 3. Let's go ahead and multiply them. Did y'all get 18? Boom. Now let's look at permutation with the formula, okay? There's a formula on this one that I want you guys to write with me. I want you to write only for permutation. Only for permutation, the formula is going to be n factorial. If you're like, I forgot what the word factorial meant, I'm going to give you a little small synopsis right after this. Over n minus r factorial. Now let's see what these stand for. My n is representing number of options. Number of options. And then r is representing the number of spots to be filled. It could be a first place, second place, and third place. That would be 3 spots to be filled. Okay, if you're ready to move on, give me a thumbs up. Okay, let's do a quick recall on factorials. So, when you were introduced with the factorial, I'm going to give you like the simpler one. 4 factorial means 4 times 3 times 2 times 1. Let's see if that is true with our calculator. And if you're like, where is my factorial? I'll tell you where that is. But after that, we're not going to use that button anymore. So first, let's do 4 times 3 times 2 times 1. So I can prove to you why these two are equivalent. Type with me. And less talking. And then type in 4. If you go to the function on math, and I believe when you go to, let's see if I remember where the there it is. The probability. So go to math, probability. Do y'all see that exclamation? Yep. Are those two typing with me? They know. I'm looking at them. Do I get the exact answer? So I just proved to you why the factorial works that way. So here I go. Okay, James, let's read example number 11. Let's apply that concept.
11 people are competing in a sack race. There is a blue ribbon for first, a red ribbon for second, and a white one for third. How many different first, second, third place finishers are possible?
Okay, so I'm going to show you with the factorial formula or the permutation formula, and I'm going to show you the way that we did on the other two problems and prove to you that they're going to work out every time. So here I go. So we know we have our formula n factorial over n minus r. And as n is representing how many options. So how many total people are racing? 11. So I'm going to write 11 factorial. 11 minus, we want first, second, and third place. How many places are those? Only 3 spots. Oh, I wrote 11 again. Did y'all notice that? Or I wrote n again instead. Minus 3 spots. And this basically means we have, the way I'm going to write out is going to be 11 times 10 times, how far do I want to go down to? 8. 9 times 8 factorial for a good reason. What is 11 minus 3, everybody? 8. And then we're going to cross something off. If I have 8 factorial on the top and the bottom, what can I do? Can I cross them out? So it's really in the end 11 times 10 times 9. Let's type that piece. So I will do 9 times 10, which is 90, times 11 is how many? 990. So now, I'm going to prove that's going to work out the other way as well. So we know we said there was 3 spots, correct? So to get the first place, we have 11 students have the potential of getting a first place. Okay, so let's say you made the first place. For second place, how many people are remaining? 10. So let's say your friend made second place. How many other how many other amount of people do I have remaining for third place?
9.
Isn't that basically 10 or 11 times 10 times 9? Okay, it's going to work out no matter what. So then let's go on to number 13. Ashlyn, let's read number 13 out loud.
In how many different ways can a president, vice president, and secretary be elected from a class of
Okay, let's start with the formula first, and we'll do the other way. N factorial, n minus r factorial. Okay, how many students are competing? 32. And then we have 32 minus how many positions? 3 positions. And the way I'm going to elaborate this is going to be 32 times 31 times 30 times 29 factorial, because I know the bottom is 29 factorial. So can I cross something identical on the top and the bottom? Let's go ahead and multiply them. Type it in. Oops. It's really big. Something in the 29,000s. Someone give me the remaining number. 29,760. And hopefully you could tell the last one, the other way will be 32. Once they get it, we have 31 remaining and 30 remaining, which in the end becomes this value right here. Okay, if we're good with that, give me a thumbs up.